Hello, I hope you're doing well, and also it's time to attack another problem. This time is the problem 2664 divisors for big integers. And the statement is it is inspired by problem 1025 and project Euler 12. Okay, so those problems help the creator to make this one. It says given n, return the number y of integers that divide n. So for example, with n equals to 10, the divisors are 1, 2, 5, and 10. So y is the number of divisor is 4. It's easy with normal integer, but how to proceed with big number? So yeah, let's try this. It doesn't seem too difficult because it's a variation of a part of the problem that we have tackled yesterday. And yeah, let's try to make this. Okay, we already made the code. Actually, it was very easy. And yeah, as I said, it's a part of a code that we tried yesterday. Let me show it on MATLAB. Here we have like the function version and also the draft. For example, let me show that any number like 66, like we get a vector that has all the possible divisors. And with this, as we know the vector, we also can know the length. So let's explain how this works. We have an input which is x, and we start with a vector that is going to have 1 and the same number, because those for sure are divisors. Even if it's a prime, these two will always be divisors. And then we do the same that yesterday. This is also done to find primes numbers and save a lot of time, which is going from 2 because we already have 1, so we don't start with 1. We go from I equals 2 to the next integer number after the root square of the number. So for example, if we go with 66, it's like 8 point something, so it will go from 2 to 9. And with that, we are gonna make a condition that if this happens, we know that we have a divisor. So for example, 66 and I equals 7. In that case, we will get a 66 over 7 that is not an integer number, and the round of that, since 7 is not a divisor of 66, we're gonna get two different numbers. And since this don't happen, we don't do anything. On the case that we are trying with a divisor, for example 66 and 6, we're gonna get 66 over 6, which is 11, and then the round of 66 over 6, which is also 11. Since this happens, is because 6 is a divisor, and also it's gonna be 66 over 6, which is 11. So we add to the vector 6 and 11. We do this for all the cases, and this is faster because we are ending with this. So that's the way we make it. It can work with very large numbers, and also it could happen that we could get repeated values on this vector. Remember that this vector is going to have all the possible divisors. At last, we just use two commands. One is sort to get the divisors order from the smallest one to the biggest one. So 1, 2, 3, 4, maybe 6, 10. And then unique. So we erase the repeating values. So if we have, for example, a vector with 1, 2, 2, 5, this erase those. Let me show it. For example, with 66, we don't get repeating values. Maybe I was a bit crazy. Let's try with 12 and also show D here. Okay, so first we get like this vector, and we see that it's very random. We get a lot of numbers, but not all of them have had any sense, right? So we first need to sort them. So now they are on ascending order, and since we also show repeating values, we use unique. So first we use sort to order this, and then we use unique to erase the repeating values, and now we get a vector with the divisors of the number. Finally, we just get the answer, which is the length of the vector. In this case, there are 6 divisors, so we get 6 as the final answer. And this can work with very large numbers, so I don't know, maybe 7, 8, 9. And let's try this. Okay, so interesting. It doesn't have too many divisors. Maybe something like, I don't know, this one. Okay, and it gets more divisors, and yeah, it shows all of them and also the answer. It's very interesting. We can try with a lot of numbers, but what we were interested on is the function version, which is basically the same that this code, but instead of getting an input, we just give the name of the function, and the input is here. So we can use it on another more complex type of codes as a function. That's the answer that we have given here, and we can see that it works for all the tests, even for very large numbers. Oh my god. So yeah, maybe we can try any of these values. Let's see if it works. I'm not sure because I haven't tried it. And yeah, we get very large values here. We can see that it's not that easy. And yeah, this is very good because it saves a lot of time for a person. If they want to know the number of divisor, they are not going to do it by hand. You can do it for very small numbers, but with very big numbers, it's basically impossible or it's very impractical. Just look at this. So yeah, let's show you the biggest number and then end this. And yeah, it's the same. It's the same. And the answer is 1000, so it can even count 1000 divisors. Also, just as a curiosity, we can also get that with just 3 lines of code. So for example, with this one, we can also get the answer because there is a command, a straightforward command like divisors, that gives you all the divisors of this number, which is this one. On the case that we try this on this example is not possible because uh, they have made sure that this code, or sorry, this command doesn't work. So we have to do it this way. And yeah, very interesting and also very useful when you want to get the number of divisors of any number or any integer. And yeah, that's it. Thank you, and also I hope you have a good time and also a good night.